Hello. Welcome to day 2 of learning Godot. Welcome to day 2 of learning Godot. Welcome. Bit of echo there. We fixed. So yesterday we went through the first tutorial from Brackeys. This one, how to make a game, Godot beginner tutorial. And when you follow along, it is pretty simple, but you notice when you try to make a small change outside of what he shows, there is a lot to learn and there's a lot of pitfalls. But you'll keep learning and growing, and eventually we will understand more. Less mistakes. Know the pitfalls before we arrive at them. Today going to be a less entertaining stream visibly, because we will be learning how to script with GDScript. Again with Brackeys.
You can zoom in by holding GDScript, a high level.
So, see if we can launch our little program.
Level, object-oriented, imperative and gradually typed programming language with syntax a lot like Python, built specifically for Godot. I know that sounds like a lot, but today we're going to learn it. While it's of course impossible to cover everything an entire programming language has to offer in just one video, we'll certainly try. In fact, we'll cover everything from variables and conditionals to getting input, inheritance, dictionaries, signals, and the list goes on. And who knows, perhaps we'll GDScript, a high-level, object-oriented, imperative and gradually typed programming language with syntax a lot like Python, built specifically for Godot. I know that sounds like a lot, but today we're going to learn it. While it's of course impossible to cover everything an entire programming language has to offer in just one video, we'll certainly try. In fact, we'll cover everything from variables and conditionals to getting input, inheritance, dictionaries, signals, and the list goes on. And who knows, perhaps we'll even figure out what GD stands for. Gandalf script? Green Day script? Gadolinium? We might never know. We'll start with the things that are considered to be most important for beginners, and then move on to more abstract programming concepts as we progress. It's not as much a follow along as it is an overview. So, if you're a beginner, lean back and know that you don't have to understand everything the first time. Also, it's totally okay to stop the video and try some of these things out. You can always come back to it at a later time. We've made sure to split everything into clearly named sections, so hopefully you'll be able to use this as a reference manual going forward. And if you're a seasoned programmer transitioning to GDScript, this video should provide you with a nice overview of the tools at your disposal, and how to approach doing different things. Keep in mind that this is a video on GDScript, not an introduction to Godot, so if you've never opened up Godot before, I suggest you begin with our video on making your very first game in Godot. Alright, without further ado, let's learn GDScript. But first, this video is sponsored by CodeCrafters. If you've been writing software for a while and are looking to take your skills to a whole new level, CodeCrafters is the place to be. CodeCrafters allows you to practice writing complex software by challenging yourself with real-world projects. You get to build your own Git implementation, your own HTTP server, or even your own BitTorrent client. Along the way, you will practice advanced system design and gain a greater understanding of lower-level programming concepts such as networking, OS interactions, and performance. And when you're done, you'll have a really impressive project to add to your portfolio. On top of this, you get to try new languages like Python, C, C++, and many, many more. Also, new challenges are constantly being added. I, for one, voted for the Compiler Challenge to be next. So become a better software engineer.
They don't have GDScript, do they?
C, C++, and many, many more. Also, new challenges are constantly being added. I, for one, voted for the Compiler Challenge to be next. So become a better software engineer today by signing up for CodeCrafters. Use the link below to get 1 week free and 40% off on all membership plans. Hello world! So here we are in an empty Godot project. It's really spacious in here. As it is custom, let's begin by making a script and adding some code to print a message. To do that, we need a test scene, so let's go and hit the plus.
Okay. Start a new project. Call it GDScript. Here we are. Blank scene. Blank canvas.
I'll add in a node, rename it to main, and let's save this as a scene. So I'll hit Ctrl S, hit save. Let's add a script by pressing the scroll. We'll use the default template, and the name of the script should be main as well with a non-capital M. This creates a script with 2 functions. We'll start by focusing
and it goes fast.
By pressing the scroll, we'll use the default template, and the name of the script should be main as well with a non-capital M. This creates a script with 2 functions. We'll start by focusing on the top one named ready. Think of this as the start of our game. As it says here, this function is called when the node enters the scene tree for the first time, which happens right when we play our game. So we can put code in here that we want to happen immediately. I'll get rid of the other function for now. You can zoom in by holding down Ctrl while scrolling. Now right now the only thing in our ready function is the pass keyword. Pass basically means do nothing, and it will appear in functions we haven't filled out yet. So let's replace it with some code that prints our message. We'll write print, and inside of the parentheses we'll put our message in quotation marks, hello world. We can then run the game by pressing this button here or hitting F5. It's gonna ask us which scene we are going to run. We'll hit select current. And while our game isn't very exciting yet, we can now see that the console prints our message. The output window here, or the console, is where it will display prints and is also where we check for errors. Now to stop our game from running, we press the stop button.
Hello world in the console. I guess that makes us pretty seasoned programmers already.
Button here or press F8. Syntax. Now, this might have worked for you and it might not. That's because there are a few things to be aware of when writing GDScript. The first is that statements like print here terminate with a new line. There's no need to add a semicolon at the end like in many C-based languages. And GDScript, similar to a language like Python, uses indentation to determine the structure of your code. This means that you use tabs to tell GDScript where your code belongs. In our example here, I'm using a tab to tell Godot that our print line belongs to the ready function. If I delete this tab, I get an error. Also, GDScript is case sensitive. So if I write print with a capital P, I will also get an error. So just a couple of things to look out for there. Now printing to the console is cool. Or I mean, maybe not as cool as backflips, but well, I can't teach you to do those. But I can teach you how to display text in the game window instead. To do that, we'll need to modify a node through script. Modifying nodes 1.0. First, we need a node to modify. Let's use a label. So I'll add a new node, choose label. I'll zoom in, center it on the screen. Make some more room. Let's add a default text. This is a label. I'll center it and override the font size. Now, to edit the text of this label through script, we need two things. We need a reference to the label, and we need to access the... First, we need a node to modify. Let's use a label. So I'll add a new node, choose label. I'll zoom in, center it on the screen. Make some more room. Let's add a default text. This is a label. I'll send...
Okay, let's see. So is either of the gonna swap me to the main? This one. This is a label. Caps lock.
Enter it and override the font size. Now to it.
Font size. So that's a theme override. 78. Better.
To edit the text of this label through script, we need two things. We need a reference to the label, and we need to access the property in the label that we want to change. In this case, the text. If we hover over text, we can see the name of the property.
Ooh, that's big. Property text. So we're gonna make a click. Gonna drag label into the script and hold control from what we learned yesterday, and it will make a reference to the label. You can then use the dot after the reference and put the property like text. So the label name dot text should reference this box, I think.
D through script, which is text with a non-capital T. So in our main script, we'll first get a reference, and we can actually do this by simply taking the label and dragging it into our ready function.
Of this, you can drag this in and hold control. Gives us a reference, and now this reference has a variable name, label. But he did it differently, he just put it straight up like this. That skips the variable name and it directly references the label like this.
Then we can access the property by going dot, and we'll type in text and set it equal to hello world. And now when we play, our label changes to hello world. And we can use this exact method to change other things as well, such as the color of the text. In fact, there is a property called modulate, which allows us to tint sprites and UI elements. In the inspector, you can find it all the way down here. Things as well, such as the color of the text. In fact, there is a property called modulate, which allows us to tint sprites and UI elements. In the inspector, you can find it all the way down here under visibility. Let's change it to green. So again, we'll click and drag to create a reference to the label, write dot modulate, and set it equal to color dot. Here we have a bunch of different colors. We'll choose green. And voila.
Horribly.
color, click and drag all the way down here under visibility. Let's change it to green. So again, we'll click and drag to create a reference to the label, write dot modulate, and set it equal to color dot. Here we have a bunch of different colors. We'll choose green. And voila, our label is now green. So this is how we can make changes to nodes when our game is running.
So if we wanted to find this ourselves, we find visibility, we see, cool, we can change the color here. Then we would hold our cursor above modulate here, and we'll see property modulate. Then we know to reference this part, we need to type dot modulate after the label.
Voila, color dot. Here we have a bunch of different colors. We'll choose
The color dot. That might be. No, it gives some information here as well, what type of variable it is and how we change it, I guess, because it says color. And you see, it doesn't. The example it gives is not like color.green though. It's color with 4 numbers, which is probably like red, green, blue, and then alpha value, which determines how see-through it is, how transparent it is. So we can reference, put modulate, sorry. We change the color. Now I wonder, like, if we put this, can we now do here? Yeah, now we get it. Now we get some information here. Red, green, blue, all floats. Might not say. Does not say the range it goes. So it's impossible to know if the range here is 0 to 1 or 0 to 255, which is common. Since it's a float, it's likely 0 to 1, and also we saw white is 1 1 1 1, and white is the max value of all red, green, blue, so it's probably 0 to 1. So if we want green, it should be 0 1 0. Okay. It's green. And maybe it gets transparent with the A is probably alpha. Set that to 0.5. You have to use the dot maybe, like this. Then we try again. No change. Might need some. Might need another object for it to be in front of to actually see the transparency. Not sure. No, we definitely see the transparency here now at 10% transparent. So that's how you can probably like use Google or something to find way where you can pick a color and get the red, green, blue number from 0 to 1 for each of these values, and make custom colors. While if you use this one, you have a lot of options, definitely. So it should be enough, but it's good to know you can always make your own. But I wonder, can you then make it transparent? Green, probably.
Green. And voila, our label is now green. So this is how we can make changes to nodes when our game is running. But right now not much is happening during our game. So let's see how we can use input to make our game respond to our actions. Input. Let's say we want to turn this label red when we press this.
Hold over hover elements in the inspector to get their property names. Once you have a reference to the node, you can access property to its property names. For example, a reference label.text to access text property. Set it to the variable you can see the variable type a prop takes while hovering. Set it to a string. Put text. Alright.
The spacebar. To do this, we first need. Let's say we want to turn this label red when we press the spacebar. To do this, we first need to set up an input action. We'll go Project, Project Settings, Input Map. Here we can add actions. Actions allow us to bind keys to something that we want to happen. Common actions would be shoot, jump, or so on. In our case, we wanted to change a color. I'll just go ahead and call it my action so we can use it later for other things. Now let's hit add, and here's our action. Let's bind a key to it by pressing plus. It's now listening for input. I'm gonna press this spacebar and
My action.
And bind a key to it, use it later for other things.
This.
Now let's hit add, and here's our action. Let's bind a key to it by pressing plus. It's now listening for input. I'm gonna press this spacebar and hit OK. And now our spacebar is bound to my action.
What is going to be important to learn later is to, like, I don't want to set up an input map for my game that is not changeable. Like people in Belgium use AZERTY keyboards and people in Norway use QWERTY keyboards, meaning WASD is actually not in the same place on those two keyboards. And yeah, the keys you use for moving depends on your keyboard. So the user should always be able to change their keys.
Then in our script, we need to create an input function. We'll write func for function _ input, and let's hit enter to autocomplete.
Alright, so input. That's probably like a built-in one then. I do it wrong.
Now just like ready, this is one of the built-in functions of Godot. But instead of being called at the start of the game, it runs every time the game receives any input, such as when we press a button. Event is what we call the information about what triggered the function. Was it a movement of the mouse or the press of a key? We need to check if the event that triggered the input was our action being pressed. So we'll write if event.isActionPressed, and as you can see, our action shows up here, my action. Then we'll put in a colon, and if we pressed my action, well then we'll change the color. So we'll drag in the label, write .modulate, and set it equal to color.red. And we can just as easily check if the action was released. We'll go if event.isActionReleased this time, my action. Well then we'll take the exact same line and change it back to green. So now when we play and I press the same line and change it back to green. So now when we play and I press the spacebar, it turns red, and when I release it, it turns back. Now when we play, take the exact same
my action. Why are you red? Action release. Right. Two. Paper green. Parse error. Right. Misses semicolon. Oh. You can see the error down here. Main GD12, so that was line 12. Expected. Semicolon after an if condition. Woohoo! Pro gamers.
same line and change it back to green. So now when we play and I press the spacebar, it turns red, and when I release it, it turns back to green. That's
Now, if anyone would like to purchase this game, I could make a build for it, launch it on Steam. Perhaps Rorschach, you would like this? It is quite entertaining.
That's right, we made a party. A disco party. Now this is just one out of many ways to handle input in Godot, but since we're focusing on the GDScript language, I'm not gonna go further into it here. I'll make sure to provide a link to where you can learn more about input if you're interested. Variables 1.0. Variables are essentially containers that hold information. In the case of a player character, we could use variables for information like the player's name, health, damage, and perhaps if the player is alive or not. Let's make a health variable. At the top here, I'll write var for variable, the name of our variable, and then we'll set it equal to a default value. Now we can print this variable inside of our ready function. We'll write print health. And if we play, you can see that it now prints.
So where did he put this script?
Further into it here. I'll make sure to provide a link to where you can learn more about input if you're interested. Variables 1.0. Variables are essentially containers that hold information. In the case of a player character, we could use variables for information like the player's name, health, damage, and perhaps if the player is alive or not. Let's make a health variable. At the top here, I'll write var for variable.
Yeah, so it looks like he actually deleted what we already did, started a new script. What I could do is comment all of this out and can write section about label text dynamically changing label text and color. New code.
Variable, the name of our variable, and then we'll set it equal to a default value. Now we can print this variable inside of our ready function. We'll write print health. And if we play, you can see that it now prints 100. Now we can easily change our variable. So before printing, let's assign a new number, health equals 40. We can also assign a calculation, so health equals 20 plus 30. We'll set our health to 50. We can also add health plus equals, and then 20 will add 20 to our health, and subtract health minus equals. To multiply, we do times equals, and to divide, we do slash equals. So if we run this now, it will do all of these calculations from top to bottom and then print out the result, which turns out to be 120. Let's look at an example where our player takes some damage and we want to subtract the damage from our health. Let's try decreasing our health variable whenever we press the action we made earlier.
GDScript. Change variable value. Path equations. Error. That's by action. You can add to the existing value of a variable by doing health plus 20. Adds 20 to the existing value of health.
earlier. So in the input function, we'll check if the action was pressed, and then we'll subtract from our health, and we can print the result. So now every time I press the spacebar bound to my
We wrote last time about key. Check if a key is pressed. Last time he checked it in physics process delta. This time he uses an input event. So I'm guessing the input event, it just reads whether the key is pressed on the keyboard. But if you put like an input is action pressed inside physics process delta, that one only runs when the game is running and the time is not 0, like it's a update loop in the game. That's physics process delta. You might want to put things like jumping there, or yeah, moving your character, stuff like this. But you might want to use the input event when you're in a menu and time is paused, something like that. GDScript can you, or you can have basic process. Check whether a key is pressed. So when do you want to use straight up use func input instead of placing input dot is action, just press. So input event, immediate raw input processing. If you press the key, whatever you want to happen happens immediately. Mouse movement, wheel scrolling, text input. Yeah. You put it inside the physics process. It's typically something that happens while you are playing the game. For raw they put this. Works while game is paused. Not need to wait for the next frame. Used for things like UI element or text.
My action, we can see that I reduced the health. Really cool. But as you can see, we can currently reduce our health below 0, and nothing happens when we do so. If we were making a game, we'd probably want our player to die and the game to restart. Luckily, we can make our game react to variables by using if statements. If statements, or conditionals. If statements are the glue that holds all of our logic together. We've actually already used if statements to check if our action was pressed, but they can do so much more.
If this, do this. Ready, don't need it. Save, play. Press button. Health goes down. However, it goes down while you hold it as well. Because we need to add press. Now it only goes down once, even if I hold it.
More. Yet they are really simple. An if statement is just a condition that needs to be met in order for the code inside to be run. Let's add an if statement here to check if our health reaches 0. So I'll make some room, write if health is less than or equal to 0. Well, then we'll set our health to 0 and we'll print that we died. And now when our health gets to 0, it prints you died. Now here we're using less than and equal to compare our health to the value 0. But there are many more comparisons we can make. Here are all the comparisons we use, such as is equal to, is not equal to, and so on. We can also add more conditions to.
Alright, so that's how the comparisons look. changing value. Put the variable, the value. Okay. Comparison. Compare value. Often used in if statement. Do this because it's a good picture.
One if statement. We use the AND keyword to add another condition where both need to be met, and the OR keyword to add a condition.
If both is true, use the AND keyword, OR keyword. Check if one of them is true.
Condition where only one of them needs to be met. Now, one really useful thing about if statements is that we can not only define what happens when the condition is true, we can also choose what happens when it's false. We do this using the else keyword. Let's add an else to print that we are still alive if our health hasn't reached 0 yet. So if our health is less than or equal to 0, we died. Else, we print, you are healthy. And even cooler, we can chain together if statements using else if or elif for short. So we check if our health reaches 0, and if not, else if elif our health goes below 50, well then we'll print that we are injured. And if neither of these two are true, we'll go to else and say that we are healthy. And if we play, we can see that at 80 we are healthy, at 60 we are still healthy, then we are injured, and at 0 we die. Very cool.
Else if health is 50, you're injured. Like, this logic is a bit weird to me though, because it first the lowest health, yeah, then the second lowest health, and then the highest health. Would probably flip it, but
note that the if statement we made here is nested under another if statement. You can easily layer if statements to get more and more specific functionality. However, try not to overdo it. You can quickly get lost in the ifs. Actually, a lot of people don't know this, but that's why programmers and philosophers have so much in common. We both tend to spend a lot of time with the ifs and the what ifs. So if you get frustrated along the way, remember that so was Plato. Anyway, that's it for if statements. Comments. We use comments to help explain and remember the what and the why of our code. Adding a comment is simple and can be done above or after a line. So if we have some code, we can make a comment above the line, and this is a comment about the code that follows, or we could make one right after, and this is a comment about this line only. We can also use comments to temporarily remove parts of our code from being executed. Here we simply put a hashtag in front of the code. And it's good practice to omit the space here to indicate that what follows is code. We can also select multiple lines of code, right-click and toggle comment. Just remember that you can't have a completely empty function. We need to add the pass keyword to avoid an error. Variables 2.0. When creating or declaring a variable, we need to think about where we do so. If we declare a variable inside of an if statement, for example, we can only use that variable inside of the if statement. This is called scope, and is something that beginners often make mistakes with. If we want to use a variable in many different places in our script, we make sure to put it at the top, outside of any functions. So
that's important. Scope. Variables declared at the top of the script are accessible anywhere in the script. Variables declared inside an if statement are only accessible in the if statement.
So this is a script-wide variable. This can be accessed anywhere in your script. If you were to declare it inside of a function, you would only be able to use it in that function. So this is a variable we can only use in ready. Now, a really cool thing about variables in GDScript is that you can declare them without thinking about what type of data is inside them. Here's a variable that is either true or false, and here's a variable that stores a number. As you can see, they're created in the exact same way. In fact, we can even change the type of data that they hold just by reassigning them. So we can
create a variable. So var bar created by var followed by variable name followed by value var health equal var x equal b or var have jump false.
can actually set our coolness to true, and this runs completely fine. That being said, we still need to be aware of what type of data we're working with, because some parts of our game will expect a specific type of data, and we will get an error if we try to use another type without converting. Now, in GDScript, we have the 4 classic data types: Boolean, or bool for true and false, integer, or int for...
We only have 4 types.
whole numbers, float for numbers with decimals, and string for text. Converting from one type to another is called casting. For example, we can cast an integer into a string. So if we have a number that is equal to 42, and we have some text, which is a string, well, then we can add the number to this text, but we convert it into a string by writing str for string, and then the variable inside of the...
Good. Converting variables, casting.
parentheses. And if we print this, it works fine. We can do a similar thing to say convert a float into an integer. So if we have a variable called pi that is equal to 3.14, then we can convert this into an integer by going int pi, and let's print this. And it prints 3, a whole number. Note, however, that this automatically truncates the number. It does not round. It simply gets rid of the decimals. So 3.9 also results in 3. Some other data structures that are really common in GDScript are vector 2 and 3. Vector 2 stores 2 floats, x and y, and vector 3 stores 3 floats, x, y, and z. These are most commonly used for positions, so I can create a variable called position with some coordinates. I can then modify one of the components, so position.x plus equals 2 adds 2 to the x component, and then we can print the whole thing. And this gives a vector 3 of 5 minus 10, 5. Now, by default, GDScript gives a vector adds 2 to of the components, so position.x plus equals 2 add
vector. And used for positions. Position. Vector 3. And we can change the x, so that's the first one, it's x, y, z inside the vector. Change the x by adding 2 to it, so that should be 5 minus 10, 5 in it. Does this function ready? Need to print, of course. Fish. Yeah, 5 minus 10, 5. That was pretty easy, but what happens if you do like position 2 as well, 80. Then you do position E. Add position 2 to the position. So now this should be like 6 minus 20, 13. If it adds them together, 6 minus 20, 13. But can I now do like only add the x? Not sure if that's gonna work. Nah, work. But what if I do position x? That work? That works, okay. If I declare I'm changing the x in the position, and I'm adding the x from position 2, and they add together. calculated similar to normal variables. However, beware to change, specify if you are changing only XYZ. Changes only X by +2. For 5 changes by 3, 5 by 4, D by 5. Better do.
Adds 2 to the x component, and then we can print the whole thing. And this gives a vector 3 of 5 minus 10, 5. Now, by default, GDScript is what we call dynamically typed. This means that we don't define what type of data a variable can hold when we declare it, which we've been using so far. This makes it fast to create variables and flexible because we can reassign data of another type at will. However, it is also more prone to error and less performant than static typing. Luckily, GDScript allows us to statically type any variables we want. We can pick and choose totally based on preference. To statically type a variable, we simply add the type when declaring it. So here, if we have a damage variable, we can specify the type and then set the value. So now this variable will always stay an integer. We can even have Godot automatically determine the data type by simply writing := and then the default value. This is called inferred typing, and the result is exactly the same. The type is still static. Godot simply recognizes that 15 is a whole number and sets the variable to a type of int. This also means that the variable cannot change to another type. If we try to set it to a string, we get an error. Now, adding export in front of a variable will allow us to set it using the inspector. The value that we set in the script will just be a default value. So if we save this and select our node, we can set a value in the inspector. If we print our damage, we can see that this updates in our game. And we can always press the circular arrow to revert back to the default. Now, sometimes you want to define a variable that cannot change. For this, we use constants. So I'll write const for constant. We'll call it gravity. As you can see, it's standard practice to name constants with capital letters, and we'll set it equal to -9.81. Now we can use this like any other variable, but we cannot change it. If we try to do that, it throws an error. And that's it for variables. Great job. Functions. Functions are the bracket and variable equal to gravity. Select our node that we can export. If we try to set it to a string, we get an error.
This is both good and bad, right? You want the damage to never change from an integer. This makes sure it doesn't. I'm not sure how you would then use this in a string, because you can't convert it to a string anymore. So let's see what GPT thinks about it. If I want to use this damage variable in a text, but this damage variable is set to always be an integer, how do I do it? Okay, so you can still cast it. So even though the variable can't change from an integer, it can be casted into string. Block variables can still be casted into string. Casted into others, such as strings. Also test it. So you can do variable damage of type here, set it to 15, print. Damage plus string damage. Save it. Damage 15. So it did work. Good.
Will always stay an integer. We can even have Godot automatically determine the data type by simply writing := and then the default value. This is called inferred typing, and the result is exactly the same.
Also, Godot can automatically look in a variable. Infer it. Lock it in. Automatically infer a variable type by doing this. Might be slightly less readable, like when you have this damage : = 5. If you're very aware while you're reading this, you understand like, okay, damage can never be changed from an integer because the colon is there. But it's much easier to skim over that. Like, if you read this line of code, it's much easier to forget that this damage can only be an integer compared to if it's written like this damage : integer. So even though you save 3 letters doing this, I don't think it is as readable. I'm not gonna do it, but it's a good option to have, of course, if you just have your code smaller, cleaner.
Same. The type is still static. Godot simply recognizes that 15 is a whole number and sets the variable to a type of int.
So using variants as a variant is where? So variant, you say variant, do you? Variables? Dot blank? Variant. all ints, floats, etc. are a type of variant. Basically a catch all type. Okay, so it's a variable type. A variant is a variable type. So perhaps you're saying like putting damage as always being an integer, it's rare to do that. Usually you would just do damage equal 15. Is that what you're saying? Yeah, I agree. Changing a variable from one type to another, it's rare indeed. But I do see converting a variable that has a number into a string, I think can often happen because you want to output text, right, to the screen, like you do 15 damage. Then maybe you want to make a string that says damage plus equals string damage. Yeah, there's definitely going to be a lot of things that is confusing to me here in the beginning. I'm not a very seasoned programmer. I see. Yeah, it is confusing to me. Hopefully, I'll try to get the basics down here. So I'm not gonna make too much trouble for myself when I start to actually code something useful. That's my main concern.
This also means that the variable cannot change to another type. If we try to set it to a string, we get an error. Now, adding export in front of a variable will allow us to set it using the inspector. The value that we set in the script will just be a default value. So if we save this and...
Okay, so export. Have export. Make it available in the vector. Add export in front of a variable declaration to allow it to be changed inside the inspector.
Select our node, we can set a value in the inspector. If we print our damage, we can see that this updates in our game, and we can always press the circular arrow to revert back to the default. Now sometimes you want to define a variable that cannot change. For this we use constants. So I'll write const for constant. We'll call it gravity. As you can see, it's standard practice to name constants with capital letters, and we'll set it equal to -9.81. Now we can use this like any other variable, but we cannot change it. If we try to do that, it throws an error. And that's it for variables. Great job. Function.
Played with the const keyword instead of var. Cannot change. Use capital letters for the name to easily remember it is a constant. Also note that at the export thing 0 isn't as good as export bar thing int 0. Yeah. Yeah, I would definitely always use the second option as well. I'm not sure why you are saying the second option is better, but I would always use the second option as well because it is more readable. Like it's there's no discussion whether it's an integer now that you put it as int instead of letting Godot automatically infer it. And also when you read it, it's much more clear that it's always an integer compared to automatically inferred version, which is very short. Yeah.
It throws an error. And that's it for variables. Great job. Functions. Functions are the bread and butter of programming. They allow you to bundle up your code in small reusable packages. So far we've been using some of Godot's built-in functions like ready and input. Notice how these are prefixed with an underscore. This is to show that they are not activated or called by us, but by the engine itself. But we can actually make our own functions and use them to do really cool things. Common functions to making games are things like jump, die, shoot, and respawn. And making a function is actually really easy. Let's make a function for jumping. So we'll write func, then the name of our function, open and close parentheses, and a colon. Then in here we'll put all of our...
Alright, next section.
our code for jumping. So we could add an upwards force, play a funny sound, and a jump animation. For now we'll just print jump. But nothing is currently triggering or calling our function. Let's call it whenever we press the action we made earlier. So func_input event, and if our action was pressed, then we call our jump function by writing jump followed by open and close parentheses. And now when I press space, it displays jump. And at this point, I encourage you to add the sound effect yourself. Boing, boing, boing. A lot of fun to be had here. Now this already makes our code more readable and reusable. But right now, our function is just a simple command. We call it and it does some things. However, we can actually use functions for much more than this. They can have inputs and outputs. Let me explain. I like to think of functions as machines. Take for example this coffee maker. Just like the name implies, it performs a function to make coffee. To do this, however, it needs some input, some water, a filter, and some ground coffee. With this, it performs its function and then spills out an output, delicious coffee.
Speaking of which, I'm gonna make a cup of coffee. Yeah. I got tempted. Coffee time.
Code we call the input we give our function parameters, and the output is called returns. So let's make a function that adds together two numbers, func add, and then inside of our parentheses we add the parameters. So number 1 we'll call num1, and the second number we'll call num2. Then inside our function we can add these together and store them in a result variable. So we'll set that equal to num1 plus num2, and for now let's just print the result. Then in ready, let's try calling this function. So we'll call add, we'll give it the first number, 3, and the second one let's do 8. And let's actually call it again, so let's do a harder one. Let's add 245 with 111. And indeed it prints 3 plus 8, which is 11, and 356, which is the result of our second calculation. So here we've created a function with two parameters, the numbers we want to add together. But the function actually doesn't return the result. It just prints it. This means that we can't actually access the result where we are calling the function, up here in ready. To return the result, we replace print with return. So we'll do return result, and now up here we can store the result in a variable, set it equal to add, and we'll add together 3 and 5. And we can print that, and the result is 8. And because we have access to it up here, we can do more things, like add more numbers to it. So we can set result equal to add, and pass in the result from before, and add 10, and then print it. And there you go, we now get 18, because 3 plus 5 plus 10 is 18. Really cool. And just like when declaring variables, we can also statically type parameters and return types to make it clear that the function is made to work with numbers. So after num1, we'll specify that this is an integer. We'll do the same thing with num2. And here we can set the return type.
Return result. Ah, yeah, you're right. Variable. There you go. Thanks. Now bring that's 5 more.
Using an arrow, and this is also an int.
Okay, specifying parameter.
Integer.
Yes.
So now this function specifies that this is an integer. We'll do the same thing with num2. And here we can set the return type using an arrow, and this is also.
Okay. Name. Set up. Parameter. Parameters can specify their type after parent. Type. Say the return variable be of type int. Functions have many names, and that might get confusing. They are sometimes called methods. In context of Godot, they are also callable. Note if you specify a non-void return type, you must return a value. It's a problem if you call the function that should return something and it doesn't return something. So I do 0.5, 5.5 and 5.5. This should return 11, right? Because it will add the floats. But will it be able to return the floats? Or will it cast it to an integer, or will it just fail? It cast it to an integer. Okay. So this is like 11.2. Then it just removes everything behind the comma. Cast it to an integer.
An integer. So now this function will only work with numbers. 3, 4, 6, 8, 2, 1, 1.5. Random numbers. Getting random numbers is very easy. The function randf gives a random number between 0 and 1. It's great for assigning probabilities to your code. Say we are deciding what loot to give the player and we want to make some loot more rare than other. Well, in this case, we could create a roll variable and set it equal to randf.
Use to generate the random number 0 to 1.
Def. Then we could check if the roll is less than or equal to 0.8, which means there's an 80% chance that we print you found a common item. And if not, well, then there's a 20% chance that you found a rare item. And if we play this, most of the time it's going to display that we found a common item. But if we keep playing, eventually there's a 20% chance, so at some point we'll eventually find a rare item. That was crazy. 18. We can also use randf range and
what is the chance? 18 attempts failing row. So I think it's like this: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 17, 18. Then you do 1 minus this, so 98.2%. Or you could say it's 1.8% chance that he would be this unlucky. One in 50. Not that impressive, I guess. Event is action. My action. I would like us to run random, I call it. Generate loot. We make a function. Here we use the roll. Then we save roll. Smaller than 0.8. Print. Got a common item. Else. Print. Got a rare item. Come on. Ah, I got it on the third try. Oof, what a streak. Ah, 2 rares in a row. That is 1 in 25 or something. One in 16. Oh.
And rand I range to get a random float or integer between a minimum and maximum value. Say to assign a random height to a character. So var character height equals rand I range for a random integer between 140 and let's do 210. And we'll print that your character is, then we'll insert the height, remember to convert to a string, centimeters tall. And we'll roll a character, and apparently I am a giant. Basketball, here I come. Documentation. GDScript is actually pretty well documented, and one of the really cool things about it is that the documentation is linked with the editor. If we hold down Control and click on some
So var range helpful and I range from int to int. So 2 to 5. Print item hold. Plus string L plus L. Now we have to see if the range includes 2 and if it includes 5. Because those are like the edges, right? So it does include 5. And it does include 2. Okay. Both inclusive.
something we would like to know more about, such as the rand I range function, it opens up the documentation right here.
That is so good. So first off, we can hover, and here it says it's inclusive. Who is lesser than from, they are swapped. How did he open it up?
Know more about, such as the range function, it opens up the
Click it.
something we would like to know more about, such as the range function, it opens up the documentation. GDScript is actually pretty well documented, and one of the really cool things about it is that the documentation is linked with the editor. If we hold down Control and click on something we would like to know more about, such as the range.
That's sick. Welcome, the real book lover. Godot is going good. I'm just learning the basics though, so we will see. I did the tutorial for the making your first game from Brackeys yesterday. And I noticed as soon as I deviated a little bit from doing exactly what he showed, I would make mistakes very fast. So today I'm learning some GDScript. Hopefully I will understand a bit more. Okay, dot blank, you avoid using ranges. You like having randomness in the range of 0.01. You can more easily multiply probabilities. You can also do the same thing as the range very simply. For example, variable random value equal base plus randf times breadth. Okay, so you avoid using ranges. Well, suppose that's fair. In a lot of like percentage probabilities and stuff, for sure you would really just be able to multiply by a range from 0 to 1. However, maybe the range could be useful to say like, yeah, like I want to roll anywhere between 2 to 5 health on my item. Maybe it's easier to just say I want the range to be 2 to 5 instead of saying 2 plus something times the random range 0 to 1. I'm not sure. Shader skills. Shaders are cool. Yeah, thanks for that, book lover. I'm sure I will still make plenty of mistakes. I'll get used to it. I'm curious as well about the shaders. So you use tutorials and a ton of trial and error to get good at shaders. I think that's a good way to go about it. Some tutorials, and then as you do trial and error, you're able to focus very specifically on the task at hand.
change function, it opens up the documentation right here in the editor. This is a really quick and easy way to check if you're using a function correctly. It also works for classes, which we'll learn about later. Arrays. Sometimes you want a variable that can hold more than one thing. In fact, sometimes you might want to store a whole list of elements. For this, we use arrays. Defining an array is very easy. Let's make one to hold items in an inventory. So we'll create a normal variable and set it equal to open and close square brackets. This creates an empty array. We can then add elements inside the square brackets. I'll add a potion string, the number 3, and the number 6. Notice how, unlike many other languages, GDScript has no problem mixing data types within an array. But if you want to constrain an array to a specific type, we can of course statically type it. So here we simply add the type. This is an array, and the elements inside it are going to be strings. So that's the syntax for that. And now we get an error because 3 is not a string, so we'll replace this with feather. And 6 is also not a string, we'll replace that with stolen harp. Now the way that we access elements in an array is by using an index. When you add an element to an array, it is automatically assigned a number based on its position in the array. In this case, the first element, potion, has an index of 0, feather has an index of 1, and the stolen harp has an index of 2. So to access and print the first element in our array, we write print items, and then we access the first element, which has an index of 0. And this spells out potion. Pretty cool. We can just as easily change elements. This changes the second element to smelly sock and the third element to staff. And arrays also have functions for finding, removing, or adding new elements. So to remove at an index, we write remove add, and then the index 1, this removes the smelly sock. And to add a new element, we write dot append, and we'll append an overpowered sword to the end of the array. Now, arrays can quickly become long and difficult to manually go over. Luckily, we can use something called loops to help out. Loops, loops, loops. Loops allow us to repeat code.
There's the basics, then there's the math part of shaders. The math part gets complicated very fast. Learning how to use shaders in general. Having a lot of issue last year figuring out how to do pretty much anything in shaders. So you put it on hold. I've heard you can use shaders for a lot of things. Shader is something I have never touched, but it's probably something I'll have to look into. So now, item 1, is that the potion? The feather. So item 0. The potion. Yeah. Then we have arrays. Note the indexing starts at 0. You can interact with an element, the array, by specifying index square bracket. Now we change item 0. Now it can't be a number, but what happens if we try? Doesn't let us. Stop. Okay. And what happens if we add item 4 or like item 1, 2? Item 3, it doesn't exist. Invalid assignment of index 3. So it doesn't let us change it. Can we add it?
A number of times with small variations. They are perfect for iterating through all the elements in an array. If, for example, we wanted to print out all the items in our array here,
by control clicking the array, get some information. Ah, this is the last item in the array, -1. Cool. -2. Counting from the back, counting from the front. I've declared an array in GDScript. Can you add new element? See if you have the element start with, and you add a 4th. Yes. You append. Okay. And add new element to arrays by doing append. Element. Array and 5. So now we can items, append, well, now we can print the item 3. Yep, all is now in the array.
We can do that easily by using a for loop. So we write for, then the name of the item that we're currently looking at, we'll just name that item. In the array, so in items, we will print out the current item we're looking at. So print item. And as you can see, it prints potion, feather, and stolen heart. This is cool because we can have any number of items in our array. The code will work just fine.
For
We
item
also
and item. Okay. For loop. Each element. Looking through each element in an array. This will direct by each element item array one by one till went through all of them. So let's say we want item list, var item, then do item plus equals plus space. But I wonder if you don't want to add the space to the last item, how would you do that? How would I add a dot instead of white space when looping through the last item? For item in item size. I see. Item. Potions, dog's feathers, stolen heart. Well, However, it didn't add a space after the first. After potion, it didn't add a space. Very potion. The item 0 is changed to smelly socks. But no, it's added. There we go. Smelly socks, feather, stolen harp. Yep. And even comma like this. Then we would need additional logic. Remove the last comma. Oh. I did notice that ChatGPT has not been very good at Godot, but I think if you narrow down your question very much, like you ask him, how do you add an element to an array? Those questions it can answer. But I don't think you can give ChatGPT an entire script from Godot and ask him like, why doesn't my character jump? It might struggle. It's better at C#, it seems.
Add more functionality, say to only print items that are more than 6 letters long. If item.length, so the amount of characters in item is greater than, let's say 6, then we're going to print that item. And now it only prints feather and stolen harp because potion is exactly 6 letters. We can also create loops that run a certain amount of times. If we write for n in 8, it creates a for loop where the variable n starts at 0, then goes all the way to 7. So if we print n, we can see that it runs 8 times and n starts at 0 and ends at 7. We say that n is the current iteration of the loop. Another type of loop is the while loop. This repeats as long as a certain condition is met. Now I think most people who know me would say that I'm a glass half full kind of person. And to those who disagree, let me go ahead and prove it by using a while loop to fill up a glass halfway. So I'll create a glass variable and default it to 0.0. The glass is currently empty, no arguing about that. Then we'll create a while loop that continues while glass is less than 0.5, so we haven't filled it up halfway yet, in which case we will add a certain amount to our glass. We could do a constant amount like this, or in real life when I try to pour something into a glass, I'm not that precise, so let's add a random number instead. So we'll add a random float between 0.01 and 0.2, and then we'll print out how much is in the glass at the current time. Then, when the loop is done, we get to continue down here in our code and we'll print that the glass is now half full. And if we run this, we can see that the glass slowly becomes more full with a random amount each time, and then it says that the glass is now half full. As you can also see, it overshoots a bit because we're adding a random amount each time and not clamping the value, just like when trying to hit exactly half a glass in real life. My wife says that I add too much milk when I make her coffee. I think I'll refer her to this going forward. Now, we actually have to be really careful when using while loops, that we don't create an infinite loop. These can be tricky to avoid and can very easily crash our program. Say if I were to remove this line, that adds a little bit to our class every time.
Not really a vibe coder, but when I try to get general directions for what functions to use, it does often go for deprecated non-existent code. Especially if it recently got an update from Godot 3 to Godot 4, it might need more time to practice the new. Then you will get a lot of deprecated code. But I must say though, if you use the free version of ChatGPT, I'm not sure how it is now. I think you have a few times you can use the 4.0, whatever it's called. But at least how it used to be is that the free version was very bad at coding compared to the paid version, in my experience. I didn't see the new sound demo from Google's AI, no. Probably very good. Growing fast for sure. 4.0 high. Sure if I have that. 4.0 mini high. 4.5. Right now I'm using 4.0. Quick coding 4.1. I'm surprised they don't have automatic model selection option where the model recognizes like, okay, 04 mini is better at this type of question than me, so I'm gonna hand it over to him for this question, and then maybe your next question will be like a more general question where you want to explore an idea for your game. Then maybe it will swap to another model, but you have to choose them manually for now. Yeah, like it's currently you have to choose the model, yeah. Like there's no problem for ChatGPT to recognize what is a coding question and what is like a philosophical question. If they wanted to add a way for ChatGPT to automatically choose which model answers, it would be able to do so. But the nice thing about choosing it manually is that you have more control, I guess, over like which one you prefer.
Well, then our glass would actually never become half full and we would be stuck in this loop forever. Now, I don't think this will actually crash Godot, indeed it didn't, but we get a lot of overflow errors, and as you can see, our game is definitely not responding. Not good. Finally, in both 4 and
while loops less than plus equal. While loops will run till the condition is met. Be careful to either have a fallback to break the loop if the condition might never be met, or make sure that or make 100% sure that the condition can indeed eventually be met.
In while loops, we can use the break and continue keywords. Break, as the name suggests, breaks out of the loop and moves on to the code after, while continue immediately skips to the next iteration of the loop.
Okay, so you have break and continue. Loops. While loop, for loop, have loop keywords. Continue. Proceeds to the next iteration. Loop. Break. Exits the loop. Moves next element in the loop. Will a break statement. A nested loop. Godot GDScript. Break just the inner loop or all the outer loop. Okay, it only breaks the loop you are writing the break statement.
Loop. So if we were to write if glass is greater than 0.2 and then break.
Yeah, they also apply for loop. Break doesn't move to the next element, just inner loop. Yeah. Exits the loop. Break the loop you execute. If nested, it only breaks inner loop. Yeah.
We can see that our while loop ends way early because we exit out of the loop before we even get to print that the glass reached 0.2. Dictionaries. They sound really boring, but they're really cool. While arrays are great for storing lists of elements, it's sometimes confusing to access each element with an index. Sometimes it makes more sense to use a dictionary. Dictionaries hold what we call key-value pairs. Let me explain. In real life, we use a dictionary to look up the definition of words in a language. The key in this instance is the word we are looking up, and the value is the definition. Dictionaries in GDScript work the exact same way. Creating an empty dictionary is really easy. We write var, I'll call this one my dict, and set it equal to some curly brackets. This is an empty dictionary. We can then add key value pairs inside the curly brackets. Say for example that we have multiple players in our game. We can use a dictionary to keep track of them. Each player has a username, this will be the key, and a level, this will be the value. So I'll create a player called Crook, and his level is going to be 1. I'll create another player, Villain, with a level of 35. And finally, a player with the username Boss with a level of 100. If defining on one line becomes too much, you can split it up like this. And it's good practice to add a comma to the last entry so you're ready for a new one. And let's name this dictionary Players. Then, to get the level of a player, we simply type in the username. Let's print the level of our villain. So print, I will write players, type in villain, and this should print 35. And you can just as easily assign a new value.
Dictionaries. False key. Value pairs. When you are going to access an element in a dictionary, refer to the key, and you often want to get the value. Diction. Cleared using var. Curly bracket. Value. Okay. E1. Bob. Print my diction. Bob. Then note you refer to the by dict square key placed in square bracket. Okay, for warning for this section, latest Godot allows types now. Are you familiar with hash map? I have not seen hash maps, no. Are they related to dictionaries? Let's make a pretend encounter. So we have a random f range. It is inclusive, so we go 0 to 2. Then we say Turn encounter. I suppose we can do more inside this thing instead. Ooh. Brain. You met how do I refer to the... I do like this. Will it now refer to the first element or no? Because usually I would have to do like group, right? What happens if I do like... key doesn't exist, yeah? You will get an error. You should guard access with a .has. Or use a safer method like get. Apply default. Dictionaries are basically a hash map if you already knew what those were. Frequently called that in other languages. Let's do my dictionary keys. Okay, so .keys. Get key. To do players.keys. Keys multiple. Keys. Key number encounter. And would this work? But if you want the random entry, do my dict value and pick random. Ah, okay. Players defined. Players are here. Maybe I need to do it up here, or players called dictionary. That. Yeah. I do encounter. Counter name.
My heart rages around like an ocean in my head because there are
Meta encounter name,
that I left unsaid.
which is level. Then player. Like that, maybe. Did I even call this? Let operator string and int there string. If this is an integer like this. Bring an int to meta and counter name. The counter name should be a string. Remove one level from line 50. Just the dot keys part. And 50. We just want the key. This. Yeah. Then. Nice. Villain. Meta villain, which is level 35. Keys. The number is the index of the key. Diction. Can access values by doing edit name. Will access the value of the given key. Nice, thanks.
Or add another entry. So we can reassign the villain here to say 50 and add a new entry called Dwayne with a whopping level of 999. And just like with arrays, we can loop over a dictionary with a for loop. When we
Oh, that's interesting. So in the dictionaries, you don't need to append. You can just add another entry like this. Then new entries, dictionary, that you just declare a new entry. ID. creates the new entry. The value of 50. Better to think of them like pools, even if they are technically ordered. Ah, okay.
To do this, we are actually looping over all the keys in our dictionary, so all the usernames. And for each username in players, we will go ahead and print out the username. I'll add a string to separate, and then the level. So here.
So there you print the keys. So the first thing referred to in for loops are keys. But I'm guessing if you do for key value in players, you will be able to get both of them. Print. Key value in players. Does not work. Can only do keys. Ah, it doesn't exist. Okay, so I can do for key, and I do value equals player's key. Variable. Nice. I have to get used to writing that variable. Variable value equal player key and value. Yeah, now it prints villain boss. Each new print statement adds a new line. And
we access our player's dictionary and input the username we're currently looking on to get the value. And remember to convert this into a string, so str, to cast to a string. There you go, it prints our entire dictionary. Now, just like with arrays, you can have multiple data types of keys and values in the same dictionary. And even cooler, you can actually have arrays or dictionaries inside another dictionary. This might sound really abstract, but it's actually pretty cool and often comes in handy. Say for example, we don't just want to store the level of each player, but also other info like their health. Well, then we simply replace.
welcome, ironic moronic. Yeah, I had to declare it. I forgot. Also, that in keyword can be deceptive. It comes with a trap. In array returns values, but in dictionary returns key. Yeah. In players. But in an array it would return a value. I believe you, Dot Blanco. I believe you.
Place this value with another dictionary. So open and close some curly brackets. Here we'll add a key called level with a value of 1. and another key called health with a value of 80. And at this point it's a good idea to use tabs to keep our code clean. Let's duplicate this. I'll assign some values. And now we can access a value by using two keys. Let's print the health of our boss, so print players. We go into our boss and we access the health. And this prints 500, which is correct. So this way we can start to think of ways we can structure data about what...
Memories are better than gold. I let you down, I know. When it started to feel so real, could feel it running, running through my lonely veins. When I started to heal, could see myself loving, loving for the rest of my days.
So it's a dictionary. Change to whatever. Did it come? Level 1. Semicolon after health. Here we go. Oh man, it will be hard to figure out all of these things for myself. Print players. There's the key. And next key. And that's the diction. First access key, main dictionary, then the key, and that's the dictionary. Oh.
What's going on in our game, such as player stats, inventory, buffs, and so on. Enums. Enums are a convenient way to define tags or states in our game. Say we're making a game with a bunch of units and we want a way to mark each one as either hostile, neutral, or ally. In this case, we could create an enum that defines these tags. So at the top here, I'll write enum to create a new enum, and then in the curly brackets, I'll write ally, neutral, and enemy. And now we can use these states in our game. For example, we can create a variable called unit alignment and set it equal to any one of these states. I'll just set it to ally. And this makes it really quick and easy to then check in our code if our unit has a certain alignment. Also, let's just give our enum a name here to stay organized. So I'm going to call this alignment. And now whenever we are accessing a state, we have to go inside of alignment dot, and here you can see our state. So I'll go alignment dot ally by default. And then inside of ready, we can check if unit alignment is equal to alignment dot, let's check for enemy. And if it is, we will print, you are not welcome here. And if it's not, so it's not an enemy, we'll just write welcome. And now if we
Enums are just constant dictionaries with some special convenience. Well, that's good to know. Oi, oi, oi. Okay.
we run, we can see that our console displays welcome because our unit alignment is currently ally. This is much safer than using, say, a string or an integer to represent states, because Godot will throw an error if we misspell a state. If, for example, I misspell enemy, we can see that Godot throws an error. But I think one of the real powers of enums is that we can use them for exported variables. To do this, we mark our variable here with export, and then set the type to alignment. And now we can actually set our unit alignment in the inspector. So I'm going to set mine to enemy here, and now when we play, it prints you are not welcome here. Really cool. Now what is actually happening?
Unit alignment is of type alignment. We export that variable, so it's visible. If it's exactly alignment. You're not welcome. Print. Welcome. Here we can choose an ally. We should say welcome. Enemy. You're not welcome. Moderator. Third with inner. Type 1, 3, created, numerator, bold, name. It holds values. Type 1, type 2. Okay. Are constants. Useful in scenarios like setting the alignment of the player to ally, neutral, or enemy. Then changing dialogues accordingly. They have auto assignment, for example, first is secretly 0, second is 1. If you print unit alignment, you will see it actually an int. Oh, it's an integer, okay. Basically a dictionary, string name, int.
Can you hear, can you hear, can you hear my
But it's a bit weird, right? Because
coming through, coming through, coming through the noise?
you basically
I'm floating
set a variable to be one of the alignments. So one of the keys then in the dictionary.
all the lights going dark and my hopes destroyed.
One of the but I would think of it like it's a value, right? You set the unit alignment to be the value. But ally is also the value 0. Both.
Calling out Mayday.
Yeah.
Calling out Mayday.
Alignment dot.
It's so dark, it's so dark
How you set it.
here in space. And it's been so long since I've seen a face. My eyes are shut, but I can
A
see
variable and then be that type of the enumerator by doing r my variable full operator name dot type. Now my variable holds the type 2. Type 2. The alignment dot. Two. Yeah. And also value of type 2 dictionary value happens to be an int 1. Yeah. It holds the value 1. But it's referred to as dot type 2 from the But if that's how it works, can you do the same with dictionaries? Can you do like my dictionary dot and then the key, like weird, because the keys, they aren't strings here, the alignment key. Like ally, for example, that's not a string. I can't do dictionary dot. Ally, if ally is a key in my dictionary. That doesn't work, I have to do ally. Dictionaries are mutable, these are constant. This allows the editor to make assumptions. I see.
Happening behind the scenes here is that Godot is creating a constant for each state in our enum. So this code here is actually completely identical to our first line. And as you can see, the value here increases from 0 to 1 to 2, kind of like an index. So an enum is essentially
Ah, here it is. They are indexes.
just a bunch of constants with an increasing value. Which means that if we try to print one of these states, say we print alignment dot enemy, the console simply shows the value of that constant.
First constant in each constant numerators are actually bigger values. First constant holds value 0. Next value. So if you print dot type 1, you would print 0. Guess you would have to bring
dot enemy,
Oh, you don't
the
have to
console
put
simply
string.
shows the value of that constant, which is 2, because it's the third state. This is rarely something you need to take into account.
Don't need a string in prints. Huh. Thought I would need it, but good to know. Alignment.keys, and you can loop over all entries. So these are the key. The dot key will refer to the constant name, and if I didn't have the key, it would just print thing in a print will auto-convert, but when concatenating strings, you do ASFD plus string 0. You can do print. Okay. Adding strings together, I need to convert it. Alignment key will return the value. Alright. Like a dictionary. Alright. This 0, 1, 2. I do something like that. A new Oh. There is no way I'm going to remember all of this, but it'll probably be easier to understand the next time I see it.
But it's nice to know what our code is actually doing. And we can even override the default value if we want. So we could set ally equal to 1, neutral equal to 0, and enemy equal to -1. And now our console displays -1 because that's now the value of our enemy constant. Now something that pairs really nicely with enums are match statements because they allow us to quickly add functionality for each state. Match. Match is the Godot equivalent of the switch statement from other languages and allows us to execute different code depending on the value of a variable. In this case here,
What game am I going to make? Hard to tell. Like, my first game, 9 Trials of Whiskers, was a simple platforming just to learn Unity. My second game, I think I want like a really fast-paced 3D combat, like big meaningful hits, where it matters really much if you use your skills in the right order, or that if you hit the enemy weak points, that you deal a lot more damage if you do it correctly. Trying to make the combat meaningful and trying to make the hits be like very impactful with things like slowing down time, adding knockback sounds and flashes, stuff like that. I just want to make something a bit more different and something very combat focused. But I haven't decided much about what the actual gameplay loop is going to be, except I have been thinking maybe I would use a system like you fight until you progress as far as you can, and once you can't get further, you can basically get reborn and start over with new passive points to allocate to talents, like actual meaningful talents, not like 1% damage, but maybe gaining a new skill or changing how often weak points show up, whatever you want to spec into, and depending on the mechanics and type of characters I have, I guess. So you can like go through the game multiple times, and each time you start over, you will have an easier time to progress, and you will be able to progress further, which gives you more points, and it will be like a loop like this. That's the only things I've thought about so far. So I'm interested to see if the first thing I'm gonna try to do, right, when I did the Godot 3D tutorial from Brackeys, I just want to see if I can make a fast-paced movement for my character in 3D in Godot, or if I can't make it feel good. That's going to be the deciding factor whether I go for that type of game or not. If I can't make the 3D movement feel good, then I'm gonna either have to go to another engine, or I'm gonna have to make another type of game. Yeah, I get what you say, dot blanco. Similar to a dictionary. And once you understand how it works.
Here we can use a match statement to add some code for the different values of our enum. So I'll write match, then the variable we are matching based on, which is my alignment, colon, and now we add code for each value. So in case my alignment is alignment.ally, I'll print hello friend. If it is neutral, I'll print a common piece. If it is enemy, taste my wrath. And a cool thing here is that we can actually add a default response as well. To do that, we do underscore colon. And so if it isn't any of the cases above, we'll print who art thou? And if we set my alignment to say enemy, taste my wrath. Modifying nodes 2.0.
Match uses the value, what you are matching to decide what code to run. That alignment are enemy alignment and ally. You can also add alt add a default fallback matches by my alignment ally function match align. The alignment is type ally. Then we print for an ally. Welcome. It's of type enemy. Print. You are an enemy. Die, intruder. Default fallback. Who are you? Alignment. My alignment variable is the step for this Okay. Does I have a big A? Run ally, welcome. The match keyword has a whole bunch of extra super crazy stuff in it. Yeah, I bet. Like, probably if I click, I can't actually control click match. You can do with everything else. Match. I have a GDScript test. You want to give some practice? The object is to figure out what this does. Okay, I can take a look at it after a tutorial, I suppose. Save it here. Test.
Taste my wrath. Modifying nodes 2.0. So far, when we need to access a node, we've done so by simply dragging it into our script, which creates a $sign followed by the path to the node. I've created a few empty nodes here to demonstrate. A player node with a graphics and weapon node, and an enemy node. So if I drag in the weapon node, it creates a path that goes into the player and finds the weapon. And we can actually store this reference in a variable. To do this, we simply drag it to the top and hold down Ctrl while releasing. This automatically creates a variable with the name of the node and the correct path. And as you can see, it uses the onReady keyword. This is because Godot has a very strict order in which nodes are created. And if we open the game and try to find the weapon node before it exists, we will get an error. OnReady simply makes sure that Godot waits until all child nodes have been created so we don't get any issues. And just a quick note, the $sign here is actually just shorthand for using the getNode function. So this is actually identical. Also, you might have noticed that the path is relative. Our script is on the main node, so it starts right after that node. We can print the absolute path through script. We'll print weapon.getPath. This prints the absolute path starting from the root of our game all the way to weapon. Now, paths are great for many things, but sometimes they can be a bit inflexible. They break if we rename any of the nodes in the path, and it's best to only use paths when the node we want to access is a child of the node we're working on. We'll talk more about parent-child relationships later. Luckily, we can also use the export keyword to reference other nodes. So if we write export and create a variable called myNode, we can set the type to node. And then in the inspector, we can assign whatever node we want, or simply click and drag. I'll drag in the player. We can also check if the node is a certain type by using the is keyword. So in ready, we'll check if my node is of type node2D, in which case we'll print is 2D. And it is. We can even be specific about what type of node we want to be able to reference. If, for example, we only want to reference sprite nodes, we just change the type to sprite. So sprite 2D. I'll reset the variable here, and now we can only assign sprites, which in this case are the graphics and weapon nodes. Now if we play, it still prints that this node is a 2D node, even though sprite 2D and node 2D are two different nodes. This is because sprite 2D inherits from node 2D, but we'll get into that in the inheritance chapter. Signals. Signals are messages that we'll get into that in the inheritance.
Okay, so is there something I need to take away from this right now, except that only make paths to children of You don't want to make paths to other objects where you might change them.
So we don't get any issues. And just a quick note, the $sign here is actually just shorthand for using the getNode function. So this is actually identical. Also, you might have noticed that the path is relative. Our script is on the main node, so it starts right after that node. We can print the absolute path through script. We'll print weapon.getPath. This prints the absolute path starting from the root of our game all the way to weapon. Now, paths are great for many things, but sometimes they can be a bit inflexible. They break if we rename.
There's better methods for handling it. Mainly unique names and port var node ref. Okay, port.
Many of the nodes in the path, and it's best to only use paths when the node we want to access is a child of the node we're working on. We'll talk more about parent-child relationships later. Luckily, we can also use the export keyword to reference other nodes. So if we write export and create a variable called myNode, we can set the type to node. And then in the inspector, we can assign whatever node we want, or simply.
Okay, so that's very handy. Export. Here are the unique. Gonna be golden nodes. As the paths may break, objects are moved around, nodes are changed or moved. Unique names, good for unique objects. You can also use export var node. This sets field for node in the inspector, which expects node of type. Expects a node. Set a node in the inspector and then have a reference to it in your script. Unique are better than at export for You have inherited scenes at export is better. Welcome, Jack Baker. Hello. Yeah, I need to learn about scene management eventually, like how it is to swap scenes and stuff like that.
Click and drag. I'll drag in the player. We can also check if the node is a certain type by using the is keyword. So in ready, we'll check if my node is of type node 2D, in which case we'll print is 2D. And it is. We can even be specific about what type of node we want to be able to reference. If, for example, we only want to reference sprite nodes, we just change the type to sprite. So sprite 2D. I'll reset the variable here, and now we can only assign sprites, which in this case are the graphics and weapon nodes.
By the way, not to beg for attention or anything, but if any of you want to like see the progress eventually as I work on Godot, and you want to come back and check how I'm doing, make sure you drop a follow. Since I'm completely new, I currently only have followers. Yeah, it would be cool if anyone would like to drop a follow. If someone did follow and I can't see it, I'm sorry. I do not know how I can see someone actually clicked follow on me. I don't have a pop-up or anything. Sorry if I miss it. Yeah, it would be cool if you dropped in in a month and could see if I actually made something or if I gave up. I'm gonna try to stick with it.
Now if we play, it still prints that this node is a 2D node, even though Sprite 2D and Node 2D are two different nodes. This is because Sprite 2D inherits from Node 2D, but we'll get into that in the inheritance chapter. Signals. Signals are messages that nodes can send to each other. We use them to notify that a certain event occurred. It's probably easiest to look at an example. Godot has many built-in signals. Take this UI button. If we select it and go to Node, we can see a list of all the signals on this node. I'm going to connect the pressed signal to our main script. So double click it, I'm going to select main and hit connect. As you can see, this creates a function called onButtonPressed, and over here there's a green arrow pointing to it. This means that a signal is currently connected to this function. If I click on it, we can see the source, which is our button. Let's just add a quick print line here. And now if we play and press the button, it prints money. Get it? Now this is because whenever we press the button, it emits the pressed signal and everything connected to it gets called. In this case,
Okay, we can try this. First, we're going to need a button.
if we select it and go to Node,
Signals are pretty important. The only important thing to really understand with signals is understanding callable, as I alluded earlier. Basically an array callable. Array callable. Well, I understand some of this, but not everything. But array function. Okay. I'll see if I understand it once I get to it here. I understand signals is a very powerful way to like connect different nodes together. That is something I have to understand. It's gonna make my life a million times better if I understand how to connect nodes together properly. Yeah, single core. Button text. Funny. Have node on the here we have a press.
Node, we can see a list of all the signals on this node. I'm going to connect the pressed signal to our main script. So double click it, I'm going to select main and hit connect.
Right. How do we do? Button press.
As you can see, this creates a function called onButtonPressed, and over here there's a green arrow pointing to it. This means that a signal is currently connected to this function. If I click on it, we can see the source, which is our button. Let's just add a quick print line here, and now if we play and press the button, it prints money.
Do double click this from a node. Assign it to another node. It will appear in its script. Ah, yeah. Vector. The node's signal. For the node section, node tab, double click a signal, choose node to connect. This node has a script. We'll now get a function that is tied to the signal. Something like that.
Get it? Now this is because whenever we press the button, it emits the pressed signal and everything connected to it gets called. In this case, our onButtonPressed function, which indeed prints money. We can connect as many functions as we want to a signal. They will all be called when it gets emitted. This is really cool because it allows us to link together nodes in a way where they don't have
Make my own thing. Yeah, I did try to make one signal in my first game. Like when I deviated a little from the tutorial, I set up just signal when the coins were collected so that the text in the UI got updated with coins collected. But if I was gonna do it again, I would just need to read up on it, how to do it. I don't remember. There's a lot of information these 2 days at once. Hard to follow everything. A lot of practice.
Have to be aware of each other. The button has no idea which functions are connected to the signal. It just tells it to emit. This makes signals great for separating different parts of our game, or decoupling. Say we're playing a character that can level up by getting enough XP. Whenever we level up, there are probably many game systems that need to update. The UI, our player stats, perhaps we have spells or achievements that unlock, and updating all of these from the player can quickly become a mess. Instead, we create a leveled up signal that all these systems can connect to. Then all we need to do is have the player emit the signal when we level up. Let's try it out.
Emit, that's right. That's how you did it. Your own signal.
Instead of a button here, I'll create a timer. So I'll add a timer node and set it to auto start. This will count down from 1, and when it reaches 0, it emits a signal called timeout. Let's connect that to our script and make it increase our XP. So we'll create an XP variable, default it to 0. Then in our function, we increase our XP, and let's also print it. If our XP then reaches, say, 20, we'll set it back to 0, we leveled up, and we can start over for the new level. And if we then play, it's going to increment
Time. Timer time. Up.
level. If our XP then
Function.
reaches, say,
Signal. You can connect the signal to an existing function by using that big option.
say 20, we'll set it back to 0, we leveled up, and we can start over for the new level.
An XP. We want to level up. XP.
And if we then play, it's going to increment our XP every second, and when we reach 20, it's going to go back to 0. Now let's create a signal that other nodes can connect to. So at the top we'll write signal, leveled up, and if we save this and select our main node, we can actually see that signal. We can connect it to other nodes, but just for this example, we'll connect it back to our main.
In the inspector. Making your own signal. There the signal. Now you can double click it in the inspector, assign it to other nodes, just like the other thing. Timer. Leveled up.
Main node. This creates an onLeveled-up function, which is called when the signal is emitted. Let's print a message that says,
Oh, this is pretty dummy. Like sending the signal. Oh, I guess sometimes you want the function the same place as the signal. To trigger on the signal.
ding.
Yeah. Let's see. Level up. But the point is that this on level up signal I could tie it to other nodes. The powerful part about it. Ding.
Now we simply have to emit the signal. Let's do that when we reach 20 XP. Here we'll write leveled up dot emit.
That's how you emit the signal. To emit the signal and trigger all connected functions, simply do dot emit.
Now when we reach 20 XP, it emits the signal and we print ding. Awesome. We can also connect signals through code. I'll disconnect the signal in the editor and instead in a ready function, I'll write leveled up dot
Oh, my timer is auto start.
connect and the name of the function we are connecting to on leveled up. Careful here, this will probably autocomplete with parentheses. We don't need those, we just want the name of the function.
So this is a way to connect, and guessing if you do this you don't have to assignment from the inspector. In connecting ready with leveled up. But will it be able to like find the leveled up signal if that exists in a different node? If I do just leveled up connect? Does find it. So I can't make so I can never make two different signals that is named the same across the entire scene.
And this could
So if I go to my label, I add a script here. Can I not? Touch a script. Then on ready, want leveled up. And that should run leveled up function. Func leveled. X. Up. Level up doesn't exist on this node. Yeah, that's what I was thinking. Maybe it would be the problem. So I would still have to go to main node, then choose the level up signal, attach that to the button on main level up, then do text up. Like a variable, but a special one. A leveled up array callable. So its scope is within the script itself, unless you connect it to the inspector here. Here you can see the connection as well. I didn't know. And now, after connecting other nodes, you can see the connection in the inspector. Something. Alright, so if I reference the main node here, then I could probably connect to the signal through code, but I would still need a reference to the node. Nice, thanks.
Connecting is just as easy. Disconnect. We can also pass parameters.
Connect. Maybe sometimes you want to disconnect and then having the connection in code is more useful. A dot then. Then we connect that to develop. To func. So if you want to do at a water level 1, can do that. Disconnect is rare, not used very often, and if you're in a situation where it's causing problems, you'll assign it wrong. Won't get autocomplete, but it does print. Okay, I can refer to my own text with just text. So text is like a existing variable already. Is that the problem? Disconnect level up. You better know. Yeah. Function, I guess. What are these? Now the text is no longer connected.
Through signals. This could be used to pass the level we reached or other useful information. I'll just add a quick message that we can print. So on a signal, we'll add a parameter. We'll make sure that our function supports this as well. And instead of printing ding, we'll print whatever message was input. And then when we emit the signal, we can put in a message. Let's put in grats. And voila, it displays grats. And that is signals. Get, set, go! Or just get set. Getters and setters allow us to add code for when a variable is changed. This means that we can do things like clamp a value within a certain range, or emit a signal letting other parts of our code know that the variable changed. The example that is always used for this is health. So we'll add a health variable, default.
Wow. Now it's been 4 hours. We still have a little bit on the video to go, but I'm gonna need a breather to like focus up a little. Suppose I can put a 15-minute break or something. Go for a quick walk, make some coffee and come back. Feel free to stay or do whatever. Meanwhile, I will be right back anyways. Yeah. Thanks for stopping by, Blanco. Thanks for all the help today. I will be right back. And we are back. So I would really like to finish this video today. 14 more minutes. I'll try to get a little less sidetracked and follow the tutorial. We have a first time chatter on as well. Thank you. The positive words.
Or just get set. Getters and setters allow us to add code for when a variable is changed. This means that we can do things like clamp a value within a certain range, or emit a signal letting
Hello, Rixion. Nice to see you.
other parts of our code know that the variable changed. The example that is always used for this is health. So we'll add a health variable, default it to 100, and then we'll use a colon to go and define a setter. In the parentheses, we name the value that was passed in. So this is the value that we are trying to change our variable to. And now we can decide what to do. We could, for example, set our health equal to not the value directly, but clamp it first between 0 and 100. So this makes sure that our health does never exceed 100 or go below 0. We could also emit a signal here, so we can create a signal. Health changed, and we can actually input the new health as a parameter. And then in our setter, we can go health changed dot emit and put in the new health. Of course, we need to make sure to connect this signal. We can do that through the editor, and let's just print the value. So we'll print the new health. Then in
You come here from another game engine, or are you new to game development as a whole? I started game development 1 year ago. I did my first game in Unity, and at that point I didn't know anything. I didn't know code or game development at all. So I learned a little bit of C# through Unity. And now this is my second day looking at Godot. So GDScript, I do not know. How do you feel about Godot? Am I liking it? Simplicity of its workflow? What to remain over Unity and Unreal? Godot seems really good, and it feels like connecting like one node to another node, making scripts actually speak to each other, connect like that. That part is a lot easier in Godot, and it's what I struggle the most with in Unity. So that's my favorite part about Godot so far, as well as now I don't know the language, but the language seems easier, and it seems like there's less errors to make in the syntax, but struggling a little bit with finding out what I'm doing wrong. For example, here now at line 6, unexpected indent in class body. Like, it's not supposed to be like this. I don't know what's wrong. But I'm new to it, so that will come with time. I'm definitely going to go through the 3D tutorial from Brackeys as well, once I'm done with the GDScript one. Then I'm gonna try to code some movement in Godot in 3D and see if I can make any kind of movement that feels good. If I can do that, I will most likely go all in for Godot for my second game and try to learn it. Using that value correct here. Getting errors out of the class body.
Ready, let's try this out by assigning a value to health. Let's try assigning -150, and now if we play, we can see that it prints 0. This is because we put in -150, it clamps this to 0, and then it emits the signal. The signal then calls the onHealthChanged function, and we...
What I can tell currently, there is no if statements for set value, then don't expect you to indent under it. Oh. Looked like that's what Brackeys did. Should be right. Fix the errors though. I need to use the set keyword that is built. Oh. Value. Saw that he's not getting an error. I could be throwing you off as I never used the set. I never used the set either.
Let's add in the queen. Change the 100 used for this is health. So we'll add a health variable, default it to 100, and then we'll use a colon to go and
Ah, he uses a colon behind here. This colon, what does it do?
changed. The example that is always used for this is health. So we'll add a health variable, default it to 100, and then we'll use a colon to go and define a setter. In the parentheses, we name the value that was passed in. So this is the value that we are trying to change our variable to. And now we can decide what to do. We could, for example, set our health equal to not the value directly, but clamp it first between 0 and 100.
Right. Values given to the variable. They are change the values being into a variable. Example. This tells us that whenever a new value is passed to health, it will be clamped in range of 0 to 100. When health is changed, it will also send health. No. Next to health, merge the colon and full. How's that work? You're learning as well? Nice. Yeah, it seems handy this, but I would probably, if I wanted to do something like this, I would probably have done something like ChatGPT did and make function when health is changed. Call the function every time I change health, but yeah. Run some piece of code when variable values change. Variable deck. Make sure piece of code is run when the variable, the values. Put an indent and a set keyword. Value. Set parentheses. The value was applied to the variable. This is really messy, but I will understand it eventually.
So this makes sure that our health does never exceed.
On yesterday's stream, the first one, Brackeys' first tutorial is about making a small 2D game, like a platformer. Today, he is only going through GDScript, like all of these different kinds of functionalities in GDScript. So there's no game today. Tomorrow or Monday, I'll be looking at how to make a 3D game. But I'm still not sure. That video, I think, is a lot about assets and art and placing things in the world, from the little I saw. I'm not sure if I'm actually going to be making a game to Monday, or what's that about? Brackeys had been using Unity for many years. Indeed. Like, he was one of the most known creators with tutorials for Unity. Then he disappeared for a few years, and then he came back with Godot. And you can see, like, it's 1 year ago is this video. So he hasn't been posting very regularly right now, but seems to be moving into Godot a little, at least. You are making a 3D game as well. That's cool. Open world FPS zombie-like game. Yeah. That could definitely be fun. Are you using Godot as well? Or are you using another engine?
$100 or go below 0. We could also emit a signal here, so we can create a signal. Health changed, and we can actually input the new health as a parameter. And then in our setter, we can go health changed dot emit and put in the new health. Of course, we need to make sure to connect this signal. We can do that through the editor, and let's just print the value. So we'll print.
So Godot is your favorite. Yeah. If you want to, you can send me a link if you have a video or something from your game, or if you have a demo or anything. Like, I would like to see how 3D looks in Godot. If you've gotten that far yet.
The new health. Then in ready, let's try this out by assigning a value to health. Let's try assigning -150. And now if we play, we can see that it prints 0. This is because we put in -150. It clamps this to 0, and then it emits the signal. The signal then calls the
Lamp, health change, health change. Why this is variant? I removed some codes. Label is not. On the timer as well. I don't need. Button press and remove all of these. But I removed the code for the button and I removed the code for the label. Missing connected method on level up, signal level up from main. You haven't gotten that far yet? Close friend feedback, yeah? That's good to start with. There's a PC rock band clone known as Yarg. And that uses Unity. Yeah, C# is a little different than Godot GDScript. Song rewind and song failing. I see. Those are useful features indeed. Well, you could always look through the scripts and see if you understand something. Like you could take a piece of code and you can break it down with the AI like ChatGPT and see if you can understand it if you go through it line by line. But jumping into a project that is really far already without knowing the language, it has to be hard. Might be an easier task to continue working on your game by that point. How Unity works. Yeah. I see. Well, it has a lot of similarities to Godot, of course, with the inspector, and you make the scripts, you make connections to the inspector, holds the variables, the public variables and stuff. But stuff on the left is like game objects which you have in the scene. The entire structure is pretty similar actually. Since there are many small differences, it's going to be difficult, I guess. Jump into something new. Oh yeah, it is working. It's printing 0 because it's clamping to, of course. Yeah, now it's printing the health.
On health changed function, and we print the new health, which is 0. So that's a good example of adding a setter. Getters are more commonly used to convert values. So let's add two variables. We'll have a chance that is equal to 0.2, and then we can
What value? What letters?
is signals. Get, set, go! Or just get set. Getters and setters allow us to add code for when a variable is changed.
Code for when a variable is changed. Getters and setters allows us to add code for when a variable changed. That's what it does.
This means that we can do things like clamp a value within a certain range, or emit a signal letting other parts of our code know that the variable changed. The example that is always used for this is health. Ready, let's try this out by assigning a value. Calls the onHealth example of two, which is our chance will have a getter. Getters are more commonly used to convert values.
Okay. Used convert values.
So let's add two variables. We'll have a chance that is equal to 0.2. And then we can have another one, which is our chance in percent. We'll make this of type int, and we will add a getter. Here, whenever we try to get the chance percentage, we'll simply return the chance variable times percentage. The chance times 100. And now if we try to print this variable, print chance percentage, or change our chance to, let's say, 0.6 and print it again, we can see that our chance percentage is completely based on whatever our chance is currently equal to. And so it starts at 20% and then goes to 60%.
Alright. So getters are a way you get another variable, do something with it, and return the result. But both setters and getters are like mini functions that run when you want to interact with the variable. So this should be like 0.2 should then be timed by 100, so you get 20, and this should be 60. Like 20 and 60. So when we print this variable, what it actually does is that it gets chance value, multiplies it by 100, and it returns it. following code when chance is requested in code will actually check the value of chance, multiply it, or get the value of chance, multiply it by 100 and turn the result. Ah, did the stream die? Sorry about that. Not sure what caused it.
And for good measure's sake, we'll add a setter also. So if we set to a new value, we will modify our chance and set it equal to the new value divided by 100. And since our chance is a float, we'll make sure to cast that value. So now
Okay. So now we're gonna have something that happens when we change chance PCT. Set value. So what is going to happen when we set a new value for chance PCT? Well, we set the chance percentage. Say we set it to 70. In that case, we're gonna change the chance, the other variable, we're gonna change it to the float of 70 divided by 100, so it becomes 0.7, for example. Get is used when requested, set is used when this is changed. Setters are used when a variable is changed. Getters are used when a variable's value is requested. Get when value of chance PCT is requested. The value of chance PCT is changed. Chance PCT equals plus E. Then we'll run the set value code since we are changing the value. Chance print chance. This will run the get code. Since we are requesting the value of chance speed. The value. Yeah. I think that's as good as I can write it.
Now, instead of changing the chance, we can directly change the change percentage to say 40. There we go. Classes. This is a good one. GDScript is an object-oriented programming language. This means that we generally try to structure our code inside of contained objects that interact with each other. We primarily do this using classes. For now, try to think of a class as a blueprint. Say for example, we are making an RPG and we need to populate it with a bunch of characters that the player can interact with. So we create a character class that has some variables and logic that all characters in the game should have. So for variables, we could add things like name, health, and a line of dialogue for when you interact with them. For logic, we could add functions like talk and die. Then we take this class and create instances. Instances are specific versions of the class. So we could create an instance named Potion Seller that has a health of 50 and a line that says, "You can handle my strongest potions." And a bunch more instances, all of which have the same variables but different values, and all of which can talk, "I used to be an adventurer like you," and die. So that's the idea of classes. In Godot, you've actually already encountered a bunch of classes. That's because all the built-in nodes in Godot are classes, which actually makes a lot.
Indeed. Hub and Chub, welcome. Yeah, starting to love it as well. This is my second day, so I have a lot to learn still, but it's looking good.
Lot of sense if you think about it. All the nodes are self-contained objects with a bunch of variables and logic that we can create instances of. If we add a sprite node, we're instancing the sprite class. So when we create a script, we are actually also creating a class. I have to put a disclaimer here that we're technically not creating a class, but for all intents and purposes, it works just like one. So let's forget all about that for now. So let's abandon our main script here for now and instead create a new node. So let's search for node and let's name this node character and add a script to it. Now to make it more clear that our script is a class that defines a character, let's set the class name to character. So right at the top here, we'll go class name. Now this node character and add a script to it. Now to make it more clear that our script is a class that defines a character, let's set the class name to character. So right at the top here, we'll go class name character with a capital C. And we can now add some variables. We'll mark these with export so that we can set them in the inspector for each character instance. So export var. Let's add a profession of type string and give each character a health as well of type integer. And so now we can see that our character here has these two properties in the inspector, and we can go ahead and fill out the profession. This is going to be the potion seller, who is going to have a health of, let's say, 40. And now we can create more instances by duplicating this node. So let's duplicate it a few times.
Can be a bit weird at first, coming from other engines, but it's very easy to get a hang of. Yeah, I get that feeling. Like, it seems like the things I struggled with in Unity is easier to handle in this engine. Like, making different scripts interact with each other, for example.
The second character here will name X Adventurer with a health of 30. And the last character will be our knight and we'll give him a health of say 150. So now we have these three instances with different properties, and we can also give them a function. So let's add a die function. So I'll write func die, and this function is going to set our health to 0, as well as print our profession and the fact that we died. And that's it for our character class, but currently nothing is triggering this function. So let's go into our main script now, and here we can get a reference to one of our characters and call the die function. We could simply drag and drop one of these nodes to get a...
Alright, hold on. Function die.
And this function is going to set our health to 0, as well as print our profession and the fact that we died. And that's it for our character class, but currently nothing is triggering this function. So let's go into our main script now, and here we can get a reference to one of our characters and call the die function. We could simply drag and drop one of these nodes to get a reference, but because we have named our class, we can actually use an export variable for this instead. This way we can set the connection in the editor and we don't have to worry about the path changing. So we'll write export var, and here we'll have a character to kill of type character. And now if we save that, we can see that our main node now has a slot here for the character to kill. And we can either drag in one of these characters or hit assign and select one. I'm going to choose character 3. And now in our ready method, we simply go to our character to kill and call the die function. And if we run this, indeed, the die function is called on our character 3, which is our knight. So it says knight died. And if we choose another character, say the first one, we are instead killing the potion seller.
Have a class name character. Now we can main reference that class for our exported variable. Here's the character to kill. Drag in one of our characters. Play the game. Potion seller died. You had chosen another character. Knight died. Here I found that a lot of my headaches from Unity went away after moving to Godot. I hope it will be the same for me. I am going to work in 3D, so I hope the engine will handle that well, especially when it comes to movement. 3D movement, probably. Classes. Player at the start. Script. Then total variable. It's a class been created. Other scripts can declare variable, type that class name, create class name character, and variables of type character. and functions. Class. Script query. Script. A variable of type character. As we just You haven't tried 3D much in Godot? 3D movement is really easy. Just hold right mouse button. And then you can use WASD and look around. Scroll wheel, zoom in and out, and control the camera speed. So you're talking about like a built-in movement functionality in Godot, I guess. Good if it has something simple like that as a starting point, then of course. Yes, actually looking around your really simple in Godot. Oh, you're talking about in the inspector, not like character movement. So you hold right mouse button, plus to look around. Roll wheel to see. Roll the camera speed. Okay. Okay. That's good. So working in the scene is gonna be easy then at least. But I'm also hoping like actual character movement is going to be smooth. That I will be able to make something fast as well. Every script is treated as an unnamed class by default. Adding a class name just means that you can use it in your other scripts by name instead of by referencing the file. Ah yeah, so sort of import functions and stuff by using the class name. Character movement is easy. They have a built-in preset for 3D character movement. Nice. I look forward to trying it.
Really cool. Inner classes. These are classes that exist inside of another class. We mostly use these for bundling together variables and maybe add a function or two. They can be a good alternative to dictionaries because they are sometimes a bit more safe to use. Say we have this character class here and we would like to add some equipment. We could create an inner class called equipment. So I'll write class equipment and then we can give it a couple of variables. I'll create an armor variable, set it to 10 by default, and a weight of 5. Now we can use this class around our script, so we could create some variables using it. I'll create a chest that is equal to equipment.new. Calling .new will create an instance of the equipment class. So now we have one piece of equipment, one instance, which is a chest. We'll also create legs, and again we'll call equipment.new. Then in the ready function, we can access these classes. So we can go into our chest and change the armor and set it equal to 20. We can then print chest.armor, or maybe print legs.weight. And this is also where you can see that this is sometimes safer than using a dictionary, because GDScript will recognize that there is a weight variable inside of the equipment class. And if we try to access something that isn't there, we'll get an error before playing the game, not only when we reach this point in our code. This is called being type safe. And now if we run this, we can see that each of the instances of our character will print these two pieces of equipment. And the armor of the chest is 20 and the weight of the legs is 5. Inheritance. So we know that all nodes in Godot
each class equipped with these two variables. These two variables are instances of the equipment class. Character class and inside the character class we'll have a equipment class that variable character class as instances the any class created any class character now have character will now have two variables, chest and legs, are of type are instances of the class. Oh man.
Are classes, and we can effectively make our own using scripts. But there's one more important thing we need to know to understand how Godot is structured: inheritance. Inheritance refers to the ability to derive one class from another. We've actually already been doing this. Notice how our script says extends node, so our script derives from the node class. This means that all the functions and variables of the node class are also available in our script. Godot actually has a very nice way of visualizing this. When adding a new node, we can see all the nodes available to us, but some of these are organized under other nodes. That's because these nodes inherit from the top ones. For example, both Animated Sprite 2D and Camera 2D inherit from Node 2D. This is because Node 2D is a base class for all things that exist in 2D space. So since both a camera and a sprite needs a position in our world, they both inherit from it. And even cooler, we can actually find our character class on this list as well. That's because when we create a character class, we're essentially defining a new node type. And we can see that it inherits from node. Really cool. Now, all of this probably sounds a bit abstract, because it is. But what it means in most cases is simply that we need to make sure we inherit from or extend the right class for what we're working with. If, for example, we are making a script that moves around our player, we would create a character body node and add a script to that node. We could name it, say, player. And as you can see, this script then automatically extends character body 2D. And we now have access to all the functionality in it, such as the velocity and the move and slide function, which moves the node around. Composition. Now, even though Godot uses inheritance for its nodes, there are often better ways to structure your code. Godot actually leans itself really well to another way called composition.
Or what I should write about that. Inheritance. Or that. Scripts. Inherits. The node use. The add character body. Means we have access to all the function variable for using character body 2D such
and the move and slide function, which moves the node around. Composition. Now, even though Godot uses inheritance for its nodes, there are often better ways to structure your code. Godot actually leans itself really well to another way called composition. I'm not going to explain that here since there's already a really good video on the subject by a channel called Bitlytic, but I definitely recommend you check that out. Call down, signal up. When writing GDScript, there are moves the node around, inherit from it. And even it's because that it inherits from or the script to that node extends composition. Now, even though Godot uses inheritance for its nodes, there are often better ways to structure your code. Godot actually leans itself really well to another way called composition. I'm not going to explain that here since there's already a really good video on the subject by a channel called Bitlytic.
Bitlytic. How you can put your codes in Godot 4.
But I definitely recommend you check that out. Call down, signal up. When writing GDScript, there are of course many best practices that we can choose to adhere to. Going over all of them is a video on its own, but one that is particularly important is call down, signal up, which we use as a rule of thumb when communicating between nodes. Every scene in Godot is a tree of nodes, and the beginning of the tree is called the root node, which is the highest in the hierarchy. When looking at two nodes where one is right above the other, we say that they have a parent-child relationship. The node that is above is the parent, and the node that is below is the child, and that child might also have a child, and so on. Call down, signal up means that nodes are fine to call functions on the nodes below them in the hierarchy, but not vice versa. Instead, nodes below should use signals to communicate that something has happened.
Hold on a lot.
Instead, a fine to call might also have a child, and so on. Call down, signal up means that nodes are fine to call functions on the nodes below them in the
Parents are fine to call signal functions on child object itself, but you want to interact parent. Object fire up. Parent. Hierarchy. Good. And then signal.
The hierarchy, but not vice versa. Instead, nodes below should use signals to communicate that something has happened. The nodes above can then connect to these signals as they choose and
But I wonder, like, how do the parents actually communicate to run the functions to children?
act accordingly. Think of it like real life. Parents are allowed to
Okie-dokie.
tell their children what to do, but children shouldn't directly command their parents to do things. Instead, children signal their needs to the parents and the parents decide the next step. Now keep in mind that this is a way to remember a good coding practice, it is definitely not parenting advice. But what if we need to communicate between two nodes that are on the same level? You guessed it, these are called siblings. Well, here the common parent is in charge of connecting the signal from one sibling to the function on the other. This is most often done in the ready function right at the beginning. So that's the idea of the rule, but of course always
Main rule. Two nodes are on the same hierarchy level. They are called siblings. They should communicate to the parent.
done in the ready function right at the beginning. So that's the idea of the rule, but of course always implementing this concept correctly requires some practice. I'll have a link to a good article with some nice examples. Style. During this video I've tried my best to adhere to the official GDScript style guide. These are the conventions we use for naming and order to keep our code elegant and readable for others. I won't go into further detail here, but I'll have a link to the official guide. That was a lot of code for one video. Of course, I haven't covered everything you're ever going to need in GDScript, but I hope this served as a nice overview of the most important aspects. Also, don't forget to check out Code Crafters. Become a better software engineer today by using the link below and get a free week and 40% off on your Code Crafters membership. So, this is the last video we've prepared for now. If you liked our new videos on Godot and have a topic that you would like to see covered, please let us know. While we don't know what the future holds, we've had a blast making these videos, and I hope you've enjoyed watching them. So, until next time, stay awesome and funky.
This man. Let's see if he puts out any new videos eventually. But for now there is one more that I will be going through, and it is making a 3D game in Godot. That is not for today, but one I'm looking forward to. I don't think
Beautifully in the engine.
he actually makes a playable game. I think this is It did show off a little bit of controller. Here there's a lot of textures, assets. World building. Nations. Oh, the bad news, the good news. What is good and what is bad? And did Godot 4 fix it? What is bad? Character. Environment lighting. Lighting is a big one. Tone map. We'll find out. Camera quality. Hey, Dot Blanco. The video is just completed. Let me take a look at the test. I'll see if I can figure it out. It extends ref counted, so that means it inherits from it. Is it? Axis, like the thing that is similar to dictionaries. The function that is named ZZ and it wants a variable named vec. Like, I guess that doesn't matter, it didn't say a type. Static function. Elements. An array. Creates an array called element. The vec variable that is passed to the function is vector2. Then it will append the x and y values from the vector into the array of elements. If it's a vector 3, it will do x, y, and z. If it's a vector 4, it will also include the vector w. I'm not sure what the w is, but it's a number, I guess. If it's a vector type of 2i, I don't know what a vector 2i is. He doesn't. Returns this class element. All right. It looks like the point is that it's gonna look at what type of vector is being given to the function, and based on the type of vector given, it's gonna like create this element array based on the values inside the vector, and finally it's going to return the vector, but as an instance of the class, maybe? Instance of Svi class that holds the values from the vector. Variable. You create the elements array. Say that we make a variable called isInteger and it's a boolean, the false. There's a new function in it, probably like initialize, like being run at once. Has one variable v, which is an array. Has a variable integer, which is set to false. Guess that is default false, and then you can change it if needed. Is integer equals integer and integer false. So is integer is going to be false, I guess. Elements equal. So this is maybe just that when you create an instance of this class, you pass it an array, which is used here to set the elements to that vector. Get property. Get property. So this is a get function. I'm not sure what that does, but it takes the property variable, which is of type string name, and it's going to return a variant variable, which I don't know what is either, but wasn't that like a type of variable, like int? We create a new variable of an array type called reordered. Can be any type, okay. For character in property is a string name. So this one like goes through one by one character and capitalizes it, I guess. Making it two upper, I'm guessing is making it big letters, capital letters. Reordered, dot append elements, axis, char. So reordered, that's the array. We're gonna add elements, axis character. So I guess that's like, but I'm not sure how that works. But maybe it's the XYZ W whatever is existing in the array that in the vector that created the class instant. Be difficult. So the class was created. The instance of this class had set integer to 0. Then it returns reordered size. Okay, so is integer is maybe to say that the values inside the vector that was given were integers. And if it was integers in the vector, then it was one integer, like the vector was one size, then you just return reordered 0, so element. But I really don't understand this part though, like you append from the elements, which is the vector, you append axis, so like that's maybe like the x-axis. You append the char. I'm guessing you then append x into the reordered array, but I don't know, like if you this is a value or probably the character x, right? So this would be x usually. Vector 2i is probably consisting of x and y. So this returns like xy probably, xyz, ycw. It's not an integer, then you match reordered size. Axis is an enum with the default value key pairs of x. Value where x would return 0. True. This is up here. So that's what axis was. DW 0, 1, 2, 3. So what is the difference when there's not an integer? Like, is it the fact that you don't use the integer vector type? another vector type. So the usage is p.cc vector 12.xx would return vector 11, vector 211. It appears to be the worst possible Whistle class ever written. I don't know what that means, don't worry. I don't even know what's Whistle. I don't know, man, like the... Does it just like return what you gave it, or what's the point? Static function. Like it creates an array of whatever vector you gave it, and gives it back. This all means to flip the order of an array. So for swapping x and y, it would be yx. Alright, but this one does like this function ZZ seems to be appending things in the correct order, right? But what am I supposed to like find here? Because this is a class and the class is named Sui. Inherits from ref counted. So I guess if you create an instance from this class, then it's probably gonna run this initialize thing. Gonna make the elements, set the elements variable to the vector given and mark the class as using integers or not. But like the get, is that then something? How was it? Is get launches if you request variable of, or if you request an instance of this class, I guess. Is that how it works? Static function just initializes the class with pre-populated data, basically already split the vector into an array. Static function. This function initializes the class with pre-populated database. Splits the vector into an array. Yeah, so this one just returns the vector as an array. Set to elements variable. So then, like, when is get called? Is that also called? If you create an instance of the class, does anything else happen then? And this just being set? Like, does the static function run? And does the get function run? All objects and instances have a get you can override. Each object is basically its own dictionary, and the get method lets you hijack the some object.variable name. So I guess this is all basically way over my head, I think is what you're saying. And it's a joke more than anything else. It's a challenge. If I grok it, I use ChatGPT though. To see if I understand it. I understand parts of it, but not everything. I think I saw most of the things being used here though in Brackeys' video. But it's 1 hour, so I'm not gonna learn the language in 1 hour. So Swissling, is that Is that like classes to learn GDScript, or what is it whistling? Whistling is remapping and projecting a vector. Things like transposing, projecting 3D to 2D. I see. But if you wanna like change a vector from 3D to 2D, I suppose there's many ways to do it, but if you just want to reuse the X and Y elements, for example, from 3D and use it in 2D, I guess that's pretty simple without any fancy tricks. This populates the elements array. Does so. It makes sure that it handles each type of vector. This if and elif could have been a match as well, probably, based on the vector type of vector. It's the same, I guess. No more, no less code. If you want to get a property, empty for character and property char. Should have said permute rather than project, but instead of just having element members like vx, vi, you can do things like vxx, vyx. Yeah, so the property vxx. Returns vectors rather than scalars with the corresponding elements in given order. So Swissling is about doing some calculations on arrays, basically. Swapping them around. Swapping around the X and Y. Stuff like that. Could convert to upper XXY, then split into XXY and get the index of them, so 0, 0, 1. Build a new array with elements the old. So the reordered is the old array then. Reordered is the new array. I see, so you can, in the get, you pass an string like, for example, xxy, like you said. And when you pass the string xxy, then that is gonna be like, you're gonna input the x from the elements array in the first and the second slot, and the y in the third slot of the reordered array. Axis. For car and semi-complicated array dictionary enum. Yeah. Like if I knew a bit more, maybe I could understand this a bit better. And it's fun to see that I at least understand parts of it after just watching a video from Brackeys. But I think they forgot something in this code. They forgot to put comments. Comments of what stuff does. But I guess that would ruin the entire purpose of having a fun challenge. Oh, you were the one that wrote this. And Well, you from 1 year ago is a bit too complicated for me. That's for sure. So, this get function, was it correct that the way you use it is that you ask to get, for example, x and y, and then is an array built with the with the elements of the original vector, like the x in the first spot, the x in the second spot, and the y in the third spot. Okay, take a look at the Godot docs object class. There you get an explanation of it. Okay. This one. Here's a method called get. Get property. Override this method to customize the behavior of get. Also note that the bottom is technically a lie. Dot sum property, it is the shorthand for dot get property. Maybe I should come back to this once I had like more practice and see. I understand 40%, I will say. Try again later. I'm not sure if I'm going to like be able to understand the technicalities of Godot so closely, even after working on it for a long time. But maybe I will learn and understand more of it. So I'll save it as something to come back to. See if next time I understand a bit more. I did pretty good. That's cool. I felt like I was off to a semi-strong start by understanding a bit of this, and then when I tried to understand like what the point of the entire class was, then I fell off. Like that was difficult, especially this get part. I did not understand the entirety of this get part. But maybe next time. So tomorrow we're off to... No, tomorrow? I think Monday. Monday we're off to try how to make 3D games in Godot. Learn a little about that, and then later next week perhaps we can start working on a small project where we make something of our own. More challenging. Ooh. I'm not sure if I need more challenging than that. That's pretty hard. Background in programming? Not at all. I did my first programming 1 year ago when I started to make my first game in Unity. I had Python for 2 weeks in school in April last year, as I was learning some machine learning. Other than that, it's just been like 400-500 hours of Unity where I worked on my game. Of course, not all of that was programming, probably 50% of it programming. Cool for game dev? Nah, I just did like a 1-year study of applied machine learning. Basically like machine learning for dummies. How to use the simple machine learning stuff. Hopefully I won't use it. Hopefully I will be able to make a game that makes money and lean more into game dev eventually. We'll see. Game dev is what I wanna do for work if I could choose. So but I do enjoy programming in while I'm making games. I think it's really cool the fact that you can like, as long as you can imagine it, if you have the skills to program it, you can actually like make it in your game. That thought is cool to me. You can have an idea of something you want to implement in a game, and if you're good enough at programming, you can make it happen. And it's a fun like problem solving task to like think what are the steps necessary to make a mechanic like what I'm thinking of work in a game. Yeah. I do enjoy it though. Usually the programmers want to be artists and the artists want to be programmers. Finding a balance is challenging. Yeah. Well, if you do game dev, I suppose you can always flip a bit back and forth and do what you want to do. If you want to do more art, there is definitely space for that in a game. If you want to lean more into the programming, like art is not everything in games. Like you'd focus more on making full mechanics from your programming. The game feel better. Maybe everyone should just become game designers. And choose yourself how much art and how much programming you want to do. Well, thanks for stopping by today. Gonna head off now. If you wanna follow for next week, just drop a follow on Twitch and you'll gonna come live, probably 8 AM Central European time on Monday again. Jack of all trades, master of none. Yeah. That's what you need as a game dev, I suppose. For all the interactions today. Thanks to you, bot524, yeah. Thanks, Blanco. Gonna need it for sure. See you later, guys.